Given the table of values, determine the degree of the function. We've done these before. This is the one where I make sure that these guys go up by the same number. They do consecutive equal length input value intervals. And then I have to test to see if these guys go up by the same. Doesn't look too promising at first. So I'm going to pretend that I didn't do these numbers ahead of time because I have a potential to screw these up. 10 to negative 3 is negative 13. Negative 3 to negative 84 is negative 81. Negative 84 to negative 305 is negative 221. Negative 305 to negative 762 is negative 457. And then last but not least, we got ourselves negative 813. So it's not linear. That wasn't even an option anyway. So let's test to see if it's quadratic. Does the rate of change of the rates of change stay constant, or do these change too? So to get from negative 13 to negative 81, I subtract 68. To get from negative 81 to negative 221, I subtract 140, so it's not quadratic. To get from that number to that number, we subtract negative 236. And then from one number to the next, we subtract 356, making it not a quadratic. Then let's do it again, see if it's cubic. Okay, so to get from negative 68 to negative 140, we subtract 72. To get from this number to the next number, we subtract 96. And to get from this number to the next number, we subtract 120, not cubic. Let's see if it's quartic, if it's a fourth degree. To get from negative 72 to negative 96, we subtract 24. And to get from this guy to that guy, we subtract 24. And oh, happy day, it's a quartic, making it a fourth degree polynomial.